Welcome back. So continuing the theme of digital thread, we've got Jonathan Girroir, and he's going to take us through the Software Engineer's Guide to Next Generation Software. Over to you.
Excellent. Thanks so much, John. And I hope everyone's having a great conference. Probably one of the last presentations today. But thank you so much for letting us talk a bit about the digital thread a little bit more and some of the tools for building that, particularly building the software that everybody is using out in industry today. And that's really what I want to talk about is the state of shipbuilding CAD software, the tools that are available to build the next generation of software, especially if you want to do that in-house, if you're a large manufacturer or a shipyard looking for maintenance, or an OEM building software, particularly for this industry. It's really exciting to be doing this because it is growing and growing rapidly compared to other building and construction 3D engineering industries, with a compound annual growth of almost 10%. And that is pretty significant compared to building and construction or automotive or aerospace. So there's a lot of opportunity and a lot of new technology coming out. And we're excited to see what people are doing with these tools to build this next generation of software, particularly being driven by rapid digitization, the complexity of our workflows, as well as the data that we have, and then also just making sure that we're compliant with all the regulations out there as well. So this was from a more recent market research report. More information if you go to their website. But I want to talk about software and the challenges of building software for our industry. We got data from a lot of different locations, so bringing data from different sources, being able to be multi-CAD enabled. The data is getting bigger as well. The ships are getting bigger, but the amount of data is getting bigger. In fact, I work with a number of different industries in 3D engineering, and some of the largest models that we touch actually come from maritime and offshore oil rigs and some of these super tankers. And so the data needs to be managed in a unique way, and there's some very unique challenges around that. But then giving access to that data, it seems like the data is coming off of people's desktop and locally and out into the cloud to support really a global workforce, and being able to create this distributed type set of tools to build software across even not just a distributed team, but an organization that might touch multiple different companies and different teams doing different things. And of course, we mentioned compliance and traceability, always very important. That's a moving target. And really, it's the bottom line is how do we get the largest return on our investment, get to market faster, and build things more affordably and more sustainably. So those are all challenges, and software is really poised to solve many of these, especially the next generation of software. So let's talk about some of the key pillars for building software for 3D engineering. It all starts with data. So it could be consuming data from another source or building your own data. But that's so critical, and that data is getting larger and more verbose every day, more complicated. At some point, it's quite possible that you're going to need another tool within your software to model. So either an actual modeling engine to build objects and surfaces mathematically, or to take one from an existing CAD system and edit it in some meaningful way. Simulation, we see more and more of that within our applications. And then, of course, we're still needing to interpret all of this, be able to drive the software. So graphics for the foreseeable future still really is part of our workflow. So it's taking all of these tools and bringing them together. And what I want to talk to you about is many of these problems are solved through a software development toolkit that you can automatically take off the shelf, put in your software, and get writing very, very unique workflows for your company, your industry, or to your specialties. So we're going to look at each of these, just kind of what's going on in that space. Start with data, look at modeling, look at simulation and graphics. So when it comes to data, it really all starts there. And as I mentioned, the world we live in really is multi-CAD, and there's so many unique formats to different large vendors in this industry that you need to be able to support. We're seeing collaboration across organizations that are using different software packages for different uses, and they want to bring that data into your unique software. And so being able to support all this data is really important, both the unique data to, say, Siemens or Dassault or PTC, but then also the standards for interoperability. We're seeing a few actually emerge, like OCX. That's a hot topic right now, but kind of more globally in 3D engineering, USD being driven by NVIDIA, Apple, Disney, and Pixar, but particularly Apple. I know Autodesk is in there as well as a kind of a new up and coming data that we're seeing need support for as well. And all of this coming together in a bespoke, like a data hub, not so much file-based, but really access-based. And so these are some of the trends is that data now isn't just coming down to the desktop, but it's being provided in some sort of cloud infrastructure, which has its own set of problems, particularly around data sovereignty. So who owns that data? Where is it getting hosted? So it does create a unique set of problems. And whatever solution you choose, you may need to take that into account. Is where is the data being hosted? How is it being used? And do I own it? Can I host it on my, let's say, a private cloud infrastructure, even a local infrastructure, cloud infrastructure, or more open and global? One of the great benefits of that is we're able to now work with much larger data sources from multiple locations. And so we can start building these really powerful sharded workflows where I'm only looking at a certain bounding region of data that might be interesting to me to investigate, or I could bring in just the mechanical system or just the hull or just the analysis data. And so really being able to not just load a file, but query a database and bring your data in. We see just a real shift in the way in which data is flowing and being utilized. Not only that, but we're really going beyond just geometry. And so we're embedding business data into this as well and relating it to that geometry, or relating it to material information or inspection data or manufacturing information or tolerance data. So this data itself is becoming much more complex. And I'd be remiss to not mention AI. We're not going to focus on it heavily today, but because of data in technology in general, that's really what is fueling this AI revolution, is access to more and more data and being able to process and make sense of that. Well, the same thing here. We sit on a tremendous amount of data, and being able to open that up for these AI workflows is really important. And one way to do that is to make it more broadly available, not through a file, but through some sort of API access to it. And already we're seeing applications in surface fitting. So we'll talk about point clouds in just a minute here, but being able to identify objects from point clouds, being able to do a part search or similarity, especially in mechanical systems. We're helping people really try to encode their 3D data to enable that. And then of course, autocomplete of design workflows. So it starts with data. Those are some of the trends we're seeing in data. There's toolkits that kind of allow that. But the next place that you tend to go is modeling. So I might bring my data in, but I need to do something with it, and say create a new hull or a new propeller, or be able to do an extrusion or boolean things together. And one of the way you do that is through a math engine called a solid modeling kernel, based on boundary representation, so mathematical surfaces, that allows you to do stuff like author, edit, optimize, query. So tell me what's there. Really a key building block to all of these CAD systems. So most of these, if you're not just building a viewer, but you're building something to actually author data, you're going to need a modeling kernel, particularly a solid modeling kernel. However, on the other side of things, if you don't want to get so complicated, we do see a slightly lighter flavor of modeling kernels that are based on triangles and meshes. This is quite helpful for downstream visualization. So you want data, this digital thread throughout your user's organization. And one of the ways to do that is that this complicated data needs to be simplified. So a mesh modeler will do that. If you're bringing data from different locations together, like mechanical and structural, there's going to be clashes. So a mesh modeling toolkit will also allow you to quickly find those clashes. process point clouds. Let's say I create a scan, I want to make a mesh from that and then fit it to some geometry. So that flavor of mesh modeling does it as well. And then we will be talking about analysis and simulation. And so those also require a mesh to seed the analysis algorithm. And these mesh modeling tools are really helpful for doing that, make it watertight for simulation, right? So that's important as well. So we got these two different worlds. We got solid modeling, we got mesh modeling. In fact, they're actually colliding into, it depends on the vendor, they're converging onto a kernel that is able to support data from both regions. And this is really a new trend, is I can work with data that might be boundary representation. I can work with data that might be mesh information. So Siemens, they call this convergent modeling. Dassault calls it hybrid modeling, but really it's being able to operate on data from both of these worlds. And so that's really something we're seeing quite a bit of now, especially as point data is being brought in and being meshed. So a real trend in the way, and we're starting to see tools build on top of that. All right, well, I mentioned simulation. So what are some of the trends we're seeing in this space, and some of the components too, the software components that go into to simulation, particularly for maritime software, but really kind of in the broader realm of 3D engineering, building construction as well. We see what we're calling a left shift of simulation and analysis. What does that mean? If you look at the span of different points of product life cycle, you go from ideation to design to manufacturing to deployment to maintenance and then decommissioning. That life cycle, we see simulation moving further and further to the left to not just design but even ideation to inform the process of design as early on as possible. So we're seeing it not just there, but then also throughout this whole design process and the life cycle of our products. And that's informing our decision making, helping us design better products and analyze how are they going to behave in the real world, and really enabling our end users, our engineers, to build better products faster. Now, sometimes that might have traditionally been outside of our software packages. So if you're building your own software, many times you need to export that CAD data to, let's say, ANSYS, and then they would do fluid analysis on it, and then you bring that data in. But more and more, because we want to keep people within our own ecosystem, we're seeing not just moving data in and out to an analysis package, but actually embedding simulation and analysis tools internally within our software. And so really that's becoming an important checkbox for any software solution these days, is having some sort of informed simulation and analysis tool within that. And because of data going to the cloud and going away from a file-based and kind of local infrastructure, being able to support that in an analysis as well as in a rendering, so being able to see the results of that analysis is important as well. And as large as our CAD models are, these analysis models get absolutely massive as well. So how do you intelligently save that and maintain it, let's say on a server, and then move it down to whatever viewer you have where your end user is? That's a kind of unique set of problems on how to kind of create this high quality rendering. And we see a new set of tools as companies are migrating their legacy software up to the cloud, some kind of unique ways of bringing that visualization data down to make sure that experience is still maintained, because they're no longer doing their simulation locally or in a local cluster, because that data is now up in the cloud, your simulation's up in the cloud, but we still need to see it and interact with it. So we talked about data, we talked about modeling. Graphics is just something you need, and because data is moving to the cloud and workflows are moving there as well, your ability to now visualize that is important as well. So a new set of tools, new set of application frameworks, but there are software components that allow you to visualize on within a browser as well, if not even better than within a desktop application. There's always trade-offs. This is always important, is how do I trade off the amount of data that I'm visualizing versus the speed or the rendering quality, right? So we have this new workforce of young individuals who are used to seeing things within, honestly, their video games and entertainment. That continues to inform the tools that we're now providing in industry too. Is there's a higher bar for the quality of rendering. They're not just happy with flat shading anymore, but and there's a set of tools and technologies that we kind of have borrowed from the gaming and entertainment industry, particularly physically based rendering or PBR. Being able to embed stuff like metalness and roughness and reflectivity is now starting to show up in some of our file formats like GLTF and I mentioned USD. And so we need to be able to render that as well. And these software components, they allow you to do that just out of the box, get higher quality rendering. And then mixing all of that together, another challenge, make sure that you have your CAD data, you have your analysis data and your business data, be able to represent that in a meaningful way and navigate it in real time. So then kind of bringing that together, something that spans really data to analysis to modeling to graphics are point clouds, especially as we're trying to either maintain and retrofit existing installs. Point clouds are becoming really important to support as well now. Setting up a scanner, let's say within this space, being able to create your point cloud, they're more accurate, they're easier to process. They're also getting bigger though. So how do we navigate and create levels of detail of that, match it? So you need to use some sort of math engine, like a modeling kernel, or to match that point cloud to your original, let's say your original data as well. So fit to that. So a lot of tools in this space. I know we've been working with Salmon Information Systems in Korea to scan the pieces of ships as they're bringing together in real time and be able to register gaps in between the parts of the ship as well. So just more scan data. So that just kind of gets thrown on the stack is how do I manage this? What intelligence can I take from it, and how do I build a workflow that adds value to my clients around this scan data? And that's so important, especially like maintenance and retrofitting, because we might not have the original or up-to-date CAD drawings. We have to go in, create a scan, and that gives us a good sense of what we have there and build that digital twin. So I talked about like all these challenges and all the tools. What's available to get you to market faster, build the next generation of shipbuilding software? Well, there's as many problems as there's as many tools and companies that provide those tools. And so just like this is a quick kind of overview of what's available on the market now to get you building software faster. So Siemens, definitely a powerhouse in this space. They have the premier modeling kernel, Parasolid, for building objects, doing extrusions and booleans and bevels and drafts and sweeps. They also have data and graphics provided by a toolkit called Hoops, which is actually from TechSoft 3D. Also in this space, we have Dassault Systems and their branch providing software development toolkits. It's called Spatial. They have their data toolkit bringing all that data in called Interop. They also have a set of modeling kernels, ASYS and CGM, which comes from CATIA. They have 2 modeling kernels. Again, they use graphics from TechSoft called Hoops. Autodesk, they have their own ecosystem. They allow you to white label either AutoCAD or Inventor. So AutoCAD for building and construction, or Inventor for mechanical design. You can take that and really it's a whole ecosystem, and you rebrand it as your own software. And we see people getting to market very quickly using those tools, just taking their product and reconfiguring it, adding their own value to it. They have a set of platform services. That's really what they're pushing forward. That's the future. They have their data hub and Autodesk platform services. It's all web-based. Data sovereignty becomes an issue there because they have the data on their systems and their infrastructure. So that's sometimes a non-starter for some people. But you get tools at each of these companies. Not independent. There are several independent companies. Open Design Alliance. In fact, we partner with them. They have data and graphics within their ecosystem. So they are independent consortium. And then TechSoft, that's who I work for. I also have a set of data access and graphics and toolkits. The Hoops brand, as you notice, we supply a lot of this technology throughout the industry. We also have a set of simulation and analysis tools. We have a partnership with Siemens. We resell Parasolid. In fact, you can't get AutoCAD OEM from AutoCAD. You can only get it from TechSoft. We're the worldwide reseller of that. So just a lot of technology there. Be happy to talk to you more about TechSoft, and we've been around for 30 years, building software for companies like NAPA and DNV and Mitsubishi Heavy Industries. ABS, kind of specifically in the maritime industry, are using our software, our toolkits. But then we also supply kind of technology to this broader space of building and construction or CAD. I know Eris was here talking to at the conference. So PLM, also visualization. We work with NVIDIA and Unity, providing data to them. So more than happy to talk to you about building the next generation. Here's where you can find out more about our tools, as well as tools for shipbuilding specifically, data access, modeling, simulation, and graphics. There's more to talk about than just for 20 minutes, but super happy to do that. You can contact us here. You can sign up for an evaluation of our tools for 60 days. My contact information is there, or you can reach out to us directly on the website.
Thank you. Well, we don't have any questions from the audience just yet, so I'll encourage them to post some questions, and if not now, perhaps later, and contact you directly. But just in the remaining moments of the presentation, shipyards around the world, in my experience, tend to do things slightly differently. You know, shipyard A will do things one way, install pipes or manufacture pipes one way, and shipyard B will do it a different way. So given that there's no common way of building ships, how long does it take to tailor a solution to a particular shipyard? Or do you have to get the shipyard to tailor their manufacturing processes to a solution?
Yeah, good question. So we normally will see, this is all custom. Like, this isn't about getting an off-the-shelf product. This is about you internally building your own software product to your unique workflow. And so that level of customization is very powerful, because instead of adapting your workflow to the product, you're adapting your product to the way you work. And normally we see, going from the day you sign up for our evaluation to actually a product, somewhere between 6 to 18 months. It depends on how complex you want to get. It depends on how many resources you may have to actually build this software. But that's usually kind of a rule of thumb. We have people that launch faster. We have people that launch take startups that take 2-3 years in stealth mode before launching a product. Very good.
We do have a question. So I think it's slightly on the technical side. What is your view on lightweight viewers, if we need them, or if we just need high performance viewers?
Well, my argument was you need a high performance lightweight viewer, and there's some very unique tricks, and that's what we're really good at. That's what these toolkits, instead of you building that, that's what these toolkits are really good at, is keep the data up in the cloud, bring down only what you need. Let's say just the shell or just your field of view. What they're rendering on is pretty limited. So a VR headset, a mobile device, a laptop, like, we can support hundreds of millions of triangles and massive models within even that type of environment. So you don't need a desktop viewer. You don't need a desktop workstation actually to get valuable business information. And that's really what we're trying to do, is you get the digital twin and you're trying to push data to all stakeholders within the organization. That's really the benefit of building your own solution, is you have control over distribution of that software, instead of being tied to a CAD license, which is heavy and expensive.
Thank you. Well, thank you for your presentation. As I say, if anybody in the audience wants to contact Jonathan, I'm sure he'll be willing to respond. Thank you, and we'll move on to the next session.
Great. Thank you, everyone.
Thanks.